Okay, this is lesson 14, percent error problems. Okay, we are talking here about measurements for Taylor, Connor, and Jordan. And the actual distance, these are the measurements that they measured. The actual distance is 15 inches. So to find the absolute error for the following problems, we explain what the absolute error means in context. Absolute error is the difference between their measurement and the actual distance. In this particular case, Taylor's measurement for measurement number 1 is 15 2/8. And we want the absolute error, so we want to find the absolute value between that and the 15 inches. So when we subtract those two, we want to find the absolute value of 0.25 because that is the difference between the two, which then would be 0.25 inches. Okay. The next thing that we are going to find is the absolute error in Connor's measurement. So Connor's is 15 4/8 minus 15. So his would be, excuse me, 0.5. So the absolute value of 0.5 would be 0.5, and that would be inches. Jordan's is the same thing as Connor's. So I'm going to move this up just a little bit. So his would be the absolute value of 15 4/8 minus 15. So that would equal the absolute value of 0.5. So again, it would be 0.5 inches. Okay, so the next thing that we need to do then is we need to find out how far that would be. So in other words, we're going to find the percent error. In order to do that, we need a formula. So the formula for our percent error is this: the absolute value of the approximate minus the exact. So this is the approximate minus the exact over the absolute value of the exact times 100. Okay, so let's look at Taylor's. So we are going to find the percent error for Tyler's measurement. Okay, and then what does this mean? Okay, so here we go. Okay, so when we find that, Tyler's measurement, again from the first page there, we had 15, the absolute value of 15 2/8 minus 15 over the absolute value of 15 times 100. So taking that absolute value, we have the absolute value of 0.25 over 15, because we took that absolute value times 100. When I do that, we have 1 over 60, because that's what that simplifies to, over 100, or times 100, which then gives us 1 2/3, and that is 8%, because when we multiply it by 100, that gives us 8%. And this means that Taylor's measurement of 15 2/8 inches has an error. That is 1 2/3% of the actual value. Okay. Now, let's find Connors. And I'm actually going to do this with the calculator so that you can see how I'm getting this number. Bring the calculator in here. I'm going to put it over here. Okay. So we can put those numbers in. Okay. So in Connors' instance, we have that absolute value of 15 4/8 minus 15 over the absolute value of 15 times 100. So we have the absolute value of 0.5 over 15 times 100. So that absolute value of 5 or 0.5, we have 0.5, okay, over 15, okay, and we have that equals, oops, it won't let us do that, so I'm going to have to put in 1/2, okay, so 1/2, okay, over 15, and I want to simplify that, and that's going to give me 1 2/15. So that's going to be 1 2/15. So that's going to be 17 over 15. I don't like that. I'd rather just multiply that by 100. I think it'll work better. There we go. That works better. I think we can just do it this way. It just makes things a lot easier. Okay. We can make it into a fraction. You can. I wouldn't. I would just make it this way. I would multiply 0.5 over 15 times 100. That's going to give us the 3. Remember, 0.3 repeating is a fraction, ladies and gentlemen, which is 3 1/3. And this is a percent. It's percent error, remember? Okay. And what that means is that Connors measurement of 15 4/8 inches has an error that is 3 1/3% of the actual value. And then Jordan's would be the same. Okay. Now it says, what is the purpose of finding the percent error? It tells you how big, yep, big, your error is compared to the true value. Okay. So next, let's do a couple exercises. I'll show you what to do. Okay, so for example, a real estate agent expected 18 people to show up for the open house, but 25 actually attended. So that is the actual, that is our X. So here we've got that A minus X over the absolute value of X times 100. So here we have 18 minus 25 over the absolute value of 25 times 100. So now we have the absolute value of -7 over the absolute over 25 times 100. So now we have 7 over 25 times 100. So here, using our calculator, okay, I have 7/25 times 100 equals 28. And that is a percent, okay, because multiplying by the 100 is giving us the percent. So that is 28%. That is our percent error. Okay. Next, in our science class, Mr. Moore's students were directed to weigh a 300-gram mass on the balance scale. Well, Tina weighed it, and she weighed that it was 328. But remember, it weighs 300, so that is the actual. So we have A minus X over the actual, which is X, times 100. So we have 328. Oh, I need a 2 in there. Sorry about that. So 328 minus 300 all over the absolute value of 300 times 100. So we have the absolute value of 28 over 300 times 100. So now we have 28 over 300 times 100. Putting that into our calculators, okay, we have 28 over 300 multiplied by 100. This will give us our percent of 9 1/3%. For our percent error. Our last problem is Darwin's coach recorded that he had bowled 250 points out of 300 in a bowling tournament. However, the official scoreboard showed that Darwin actually bowled 225 points out of 300. Okay, so here we've got A minus X over X, the absolute value of X times 100. Now remember, the A is the approximate, it's the estimated, okay? So he had recorded that he bowled the 250, okay? But it actually, okay, bowled 225. So the absolute value of 225 times 100. So we've got the absolute value of 25 over 225 times 100. So now we have 25 over 225 times 100. That will give us our percent error. Okay. So let's multiply that out. We got 25 over 225 multiplied by 100. That will give us our percent of 11 and 1/9. And you actually write that out. You write out the 1/9, 11 and 1/9%. That is your percent error. Okay. And that is our lesson for today.